Hello everyone and welcome back to my channel. In today's video, we will discuss something interesting about the thermal and mechanical calculation results about the main engine S60MC. In its section view, you can see some main moving parts such as the piston rod, the crosshead, the connecting rod, and the crankshaft here. Now, let's go to our detailed model here. This is a cross-section for a single cylinder, as you can see. Let's follow how the lubricating oil flows. As you can see here, on this cross-section plate, this hole will be connected to a telescope pipe which is used for the convey of the lubricant. Let's move to that view and see it. You can see the lubricant can flow inside this, right, and go into the center hole of the crosshead pin, right, and here the lubricant will be delivered to the crosshead plate. There are several holes for the lubricant. Along this hole, when it goes to here, the lubricant will go upward into this center pipe of the piston rod and go into the piston. Alright, the lubricant oil will be flowing to here, and through those holes, you see here, the holes on these surfaces, they will convey the oil into here and flow back into this space. So that part of the oil is used as a coolant for the piston head, and the heated oil will be delivered to these two holes in the crosshead pin. They will flow until they reach here and goes to another crosshead plate and be going to here. The view is not that clear, but you can see they will reach here, right? They will flow down, alright? Because they are heated and might contain some contaminations because the oil is heated under the piston head, so they won't be used as a lubricant for the bearings. Now let's move back to here. Beside those part of the coolant oil, the lifted oil will be conveyed here, alright, for the lubricant and the crosshead bearing, and they will be delivered through this passage inside the connecting rod and be used as a lubricant for the main, not the main bearing, but the bigger end of the connecting rod bearings. Alright, and another crosshead plate needs lubricant as well, so you know those are holes for the lubricant. Alright, and let's change over our view. Okay, here are the 6 cylinders, the main moving parts together with the cylinder jacket. You can see it can rotate. And here is a simplified model for the crosshead, connecting rod, and crankshaft mechanism. Here you can see is the crosshead part due to the view, it's not very clear that on this left side there is a side force, horizontal force, and here is a force along the connecting rod, which will be actuate on the crankshaft pin. Alright, here. And I did some detailed thermal calculations which shows the indicator diagram like this. Here is the end of the scale engine, which also represents the start of the compression stroke, which will end here. At this point, the fuel is injected and the pressure will be increased to this point P. And after the P is reached, you may notice that both D and P, the piston is at the top dead center, right? After P point is reached, the piston will move downwards. So the volume is increased, but the combustion is also taking place as well. So this part PE process, the pressure inside the cylinder remains the same, or roughly remains the same. This part, the combustion already, or not already, but the combustion intensity of the combustion is decreased, so the pressure will decrease. Alright, some fuel is still combustion in this process. We have taken that into the calculation, but just for some simplification, we draw this process like that. Alright, and we can use another angle to draw that diagram like this. This axis represents the crankshaft angle. Alright, you can actually calculate the cylinder volume, the volume inside the cylinder using the angle, right? Because the mechanism is like this. You can use this angle to represent the move of the piston or the crosshead, right? So you can draw the pressure graph like this. Also another kind of the indicator diagram. This part represents the exhaust valve opening. And this is the side force or the horizontal force on that crosshead. Let's change the view for you to see it. Alright, so you can see this line represents the zero horizontal force, which will be made when the crosshead is at the top dead center, 0 degrees, and the bottom dead center, which is 180 degrees here, right? The zero force. Alright, and another interesting thing is that the horizontal force is quite huge in such an engine. Alright, that's very huge in newtons. The force is in newtons. 360 degrees as well. Zero position. And here are also two zero crossing points. I'm not sure what that represents, but we will see later. Here is the force along the connecting rod. You see it's even more larger than the horizontal force on that crosshead. Change the view. The force on the connecting rod. This part is due to the exhaust valve opening. This is a graph which indicates the single cylinder torque. You can see the torque can reach its peak at this point. You see? And let's see what is the next. This one. This one is the force, the composed force, which acts upon the main bearings. Main bearings or the main joints at the crankshaft. Alright. Let's see what is the next. This is the composed second order inertia force torque, referring to the position where the first crankshaft angle is. And I remember the next thing is the composed torque of the whole engine. This is quite simple since we just need to add up all the single cylinder torques, and you know that torques, and it must follow the firing order. Yeah. And this is the fuel cam profile we designed for the engine. This is the fuel cam profile. And due to the fact that the main engines on a ship need to operate in reverse operation, right? So not this graph, this one. So we designed the fuel cam in a symmetrical design so the engine can be operated reversely. This is done by the main BMW as well, and we borrowed their design. You can see the hydraulic oil inlet hole for helping to tune the firing angle, right? If you are a marine engineer, you can understand what I mean. So this is a fuel cam profile, you remember, and we designed the symmetrical fuel cam according to this one. Alright, so let's see what's left. It's a fuel pump. We can see the fuel pump is also designed according to the main BMW design. Let's change the view. Maybe this will be better. Okay. So let's see what is the fuel pump like. Something like this. Okay. I will say that this shape here is due to the cutting face I made. You understand that, right? So let's see how this fuel pump works. Here is the plunger and the barrel, just like the famous Bosch pump. And here is the suction valve. The oil will be supplied to the outer space here, and through this hole, suction hole on this barrel, right? The fuel pressure will be act upon this surface here, and when the inner pressure of the high pressure volume is low enough, the pressure will actuate on here and push this suction valve upward, this direction upward, and the fuel will be able to flow inside this space, right? And when the plunger is moving upward, the force inside is greater than the outside. Together with the help of this spring, this valve will be closed and the high pressure fuel will be delivered through these passages, through here, and through here to the high pressure injection pipe to the fuel valve. How the fuel valve functions, there is already a video in my channel, and I have put the description of that video under this video. If you are interested, you can take a look. Here is a puncture valve on the main S60MC fuel pump. High pressure control air will be supplied here and push downward this air piston. This gray thing is the air piston. The black things are actually the O-rings. Alright, so the high pressure air will activate this downward and will push down this valve. You can see actually here this is a small valve, but due to the angle I cut this model apart, it's not quite easy to see that. This is a valve. Alright, a spring loaded closed valve under normal condition. When the high pressure air is supplied, this valve will open and the high pressure fuel, remember, the high pressure fuel from here will go through this passage and be leaked to this space. And there is also a passage inside the pump cover as well, which can deliver this leaked oil downward down to here. So that actually means the high pressure pump no longer supplies the fuel to the injector when you supply the high pressure air to this puncture valve. Alright, that is used for the air start procedure of the main engine or the emergency stop of the engine. Because in the air start procedure, if you supply too much fuel into the cylinder, that will lead the engine knocking or to acute pressure building. Alright. Also, the fuel is not allowed to enter into the air starting system, since the accumulated fuel will lead to the explosion of the starting air pipes. Alright, so during the air start procedure, the fuel is cut off. So this is a fuel pump function, and another interesting thing about the MC series pump is that it is a variable injection timing pump, which means not only the start of the injection can be adjusted, the end of the injection can be adjusted as well. So if you are very familiar with the fuel pumps, you may notice that the plunger assembly, like this, has something like this, the flow back port, right? So the end of the injection is actually adjusted by this barrel according to the fuel quantity, right? So how do they adjust the start of the injection? They just move this barrel upward or downward. This barrel upward or downward, referring to the cam, the center of the cam. So how is this accomplished? It is accomplished by the spiral shape here. You can see that spiral face here and the adjusting ring here. They are a mating surface, and with the help of the rack and the screw outside this adjusting cap, or the adjusting ring I call it, with the help of the rack and this gear, this ring can rotate and the mating spiral surface will move upward or downward this barrel, right? That is how the VIT, variable injection timing system, works. Here is the VIT rack. Here is the fuel valve, not the fuel valve, the fuel quantity rack. Alright, and here is the spill oil hole for the umbrella sealing of the barrel. So that's almost enough for today's video, and I hope you enjoy this video, and I hope you have learned something in this video. See you next time.